Module 3, Lesson 36 is really the multiplication problems that we have been waiting to get to. I know that we love 1 by 1 digit multiplication and 2 by 1 digit and 3 by or 4 by 1 digit multiplication, but when we start having multi-digits in both of the place values, that is realistically where we're going to use multiplication in the years to come. So what I have in front of you is a few problems that represent how to take a multi-digit by multi-digit multiplication problem and break it into methods that we feel most comfortable with. So in this first problem, it says, in each of the two models pictured below, write the expression that determines the area of each of the 4 smaller rectangles. So I'm going to start with this one using the graph paper. And if I count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. This is 2. With me so far? So this total length is 12. On the sides, we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which gives a total length of 14. If I come back over here, I can see 4 and 10, just like I see up here, and 10 by 2, just like I see over here. What I am essentially doing is I'm going to take our numbers and represent them in expanded form. So 10 and 2, 10 and 4. Now I just happen to put 4 on top and 10 on bottom. I could have this reversed, it doesn't much matter. But this area right here would represent 4 times 10, and if I count that up, it would be 10, 20, 30, 40. Okay? This area is 10 by 10, which would equal 100. This space would be 10 by 2, or 20. And this space is 2 by 4, which would be 8. And the same thing over here. 4 by 10, 40. 4 by 2, 8. 10 by 10, 100. 10 by 2, 20. And from that point, if you see down below, we kind of use this distributive property, okay? We write the area as smaller problems. So this 14 times 12 is the same thing as 4 times 10, 4 times 2. And I just took the 4 and multiplied by the 10 of 12, and 4 times the 2 of 12. Then I have the 10. I get that from this point, and I multiply it by the 10 of 12, and the 2. And so at this point, 4 times 10 is 40. 4 times 2 is 8. 10 times 10 is 100. 10 times 2 is 20. And what I do is I take any of these items and I add them up. So I'm going to take my largest, my 100. It doesn't really matter. Plus my next largest, which would be 40. That would be 140. Then my 20 would be 160, plus 8 would be 168. Okay, so all I've done here is I've taken my partial products, I added them up just like we had a 2-digit by 1-digit multiplication. In this case, we have 4 smaller partial products. Down below, we have the same area model, the same problem. So in this case, I'm going to have this 4 by 10. Or 4 and 10 equals 14. In this case, this is going to be 20 and 2. So, equaling 22. So in this box, it's going to be 4 times 20. And I do this by kind of almost a multiplication chart method. Over here, I'm going to do 4 times 2. Here, I'm going to do 10 times 20. And here, 10 times 2. And so 4 times 20, well, 4 times 2 is 8, add the 0. 4 times 2 is 8. 10 times 20, well, 1 times 2 is 2, add the 0. That would be 200. And 10 times 2 is 20. So 8 plus nothing would be 8. 8 plus 2 would be 10, carry the 1. 2 plus 1 is 3. The answer should be 308. It's all about organization. You just see if I line it up based off these expanded forms, I make them into smaller but manageable multiplication problems we are quite familiar with. So we're going to look at 2 more problems. In this case, we're going to take the area model and represent the expression as partial products vertically and solve. So here we go. I know that 25 is 20 plus 5, and 32 is 30 plus 2. So I create an area model, and it doesn't need to be perfectly accurate. So 30 plus 2, 20 plus 5. This 20 times 30, well, 2 times 3 is 6. Add the 2 zeros, 600. 20 times 2, well, 2 times 2 is 4. Add the 0, 40. 5 times 30, well, 5 times 3 is 15. Add the 0. 5 times 2 is 10. So I'm going to take 600 plus 150 plus 40 plus 10. 0, 0, 0, 0 would be 0. 5 plus 4 is 9, plus 1 is 10, carry the 1. 6 plus 1 is 7, plus 1 is 8. Okay? Now in our last problem down below, it's going to ask us to try and solve it without using the area model. So let's look at this problem. 42 times 11. This is where I'm going to break out 2 different colors. Okay? I'll do a light and a dark purple. Hopefully that shows up. So at first I'm going to do 2 times 1, and that is going to be 2. 1 times 4 is going to be 4, but it's not 1 times 4, it's 1 times 40, which would be 4 in the tens place. So I'm going to get 42. Now I'm going to do 1 times 2, but it's not 1 times 2. It's 10 times 2, which is going to make 20. But 1 times 4, although it's not 1 times 4, it would be 10 times 40. Well, 10 times 40 equals 400. So I add that to the 20, and I add up both partial products. Now, I could have done 2, 40, 20, 400, but I kind of streamlined it. 2, 6, 4. Our answer to 42 times 11 is 462. And I want to just show you, I could have done this 42 times 11. Okay, 2 times 1 is 2. 1 times 40 would be 40. 10 times 2 is 20, and 10 times 4D would be 400. So 2, 6, 4, I get the same exact answer.